Hello everyone, my name is Kevin Bradley. This video provides further detailed insight into my final project for CSCI-E-63 at Harvard Extension School. My project uses Elasticsearch, an open source enterprise search solution based on Apache Lucine's engine, to ingest, search and analyze a dataset of over 4 million records of the 2008 United States presidential campaign contributions. Let's start by providing the agenda for this video. Here's the agenda. I'll start by describing what is Elasticsearch, users of Elasticsearch, some of the features, the concepts associated with Elasticsearch, installation and setup, ingestion and querying of a sample document, a solution accessing Elasticsearch via the Java API, and I'll conclude by discussing the pros and cons of this technology. What is Elasticsearch? It's a highly scalable search solution. It stores its data in a structure known as an inverted index that is optimized for full text, language-based searching. It utilizes the concepts of distributed computing by allowing clustering, replication, and failover out of the box. It uses JSON objects to accept data and return responses via RESTful API. It is highly configurable, but comes out of the box with very reasonable default settings, allowing users to quickly get up and running. It has the ability to search in 32 languages. Elasticsearch is one of the most highly adopted open source search solutions on the market today and is used by some of the world's largest companies. The following is a list of some of the companies which adopt Elasticsearch technology: GitHub, LinkedIn, Wikipedia, Netflix, eBay, WordPress, Tesco and Target, just to name a few. The features of Elasticsearch: it provides a RESTful API, allowing loose coupling of systems and easy access to the data from a range of systems and layers. Spatial search, searching a document based on its latitude and longitude. Faceting, an efficient computation of document counts grouped on a particular field, i.e. presidential candidate, which we'll see later in more demonstrations in solution file. Spell check, checks the spelling of a particular word and provides alternatives. Autocomplete, the ability as a user types to provide suggestions. More like this, a feature which allows an algorithm to determine documents which are similar to the one selected based on a particular field, i.e. content. This is configurable. Filter queries, allows a user to select a subset of the data. Joins, the ability to search inter-document relationships. Aggregated functions, to provide averages, sums, standard deviation, etc. Span queries, identify matches which are near to each other based on configurable parameters, i.e. slop. Highlighting, highlights the part of the text which was searched, providing context back to the users. Synonyms, ability to map certain acronyms onto useful words, UN onto United Nations. Complex documents, the ability to ingest complex documents, not simply flat documents. Apache Tika integration, integration with Apache Tika allows for extraction from various document types, i.e. PDF, MS Word, etc. Node auto detection, starting a new instance with the same cluster name. The system automatically detects this new node of the cluster. This allows scalability to be very easy. Importability with a range of data sources, JDBC, RSS, Apache Solr, Twitter, Wikipedia, Neo4j graph database, LDAP, but to name a few. The concepts associated with Elasticsearch. So there's a cluster. A cluster is a number of computers which work together to form a network of machines focused on a single task using the example technology, i.e. Elasticsearch. A node is a single instance of Elasticsearch. An index is a collection of information stored under the same umbrella, but not necessarily the same type. Think of an index as a project with different classes within. A type is a particular structure or schema. Think of a type as a class. Document, a document is a single instance of a type or an object of a class. A shard is a slice of data, Imagine splitting up a large data set and spreading this across multiple machines. A shard is a piece of that information and can be duplicated across multiple machines to provide redundancy and improve performance. A replica, as the name states, is a replica of the index over multiple locations and machines. So now what we'll do is we'll install Elasticsearch and get it up and running. So the first thing you have to do before you can install Elasticsearch, because it's a Java based solution, is you have to install Java. I won't get into that in this particular tutorial because of time constraints, but I've already installed Java. You can find online many instances of how to install Java on your machine. So I'll just verify that I've installed Java. As you can see here, I'm using 1.7, which is Java 7. Optionally, you can install curl or the head plugin, which comes along with Elasticsearch, or some other mechanism to call a RESTful API. I've installed curl. I'll just show you that. There you go. So you can see I've installed both of these components. So the first thing we'll do is download Elasticsearch, unzip and store it in a relevant location. So I'll keep this window here because we'll need it eventually. I'll just bring up. So if I go to Elastic, the place to download Elasticsearch is here, elastic.co. If you come up here on the right hand side, click Downloads, Elasticsearch, and you can download any one of these files. I'll download the zip file, I'll store it on my desktop, I'll pull it over here, I'll unzip that. I'm using the GUI to do this, but you could easily do this via the command line. So in here, if I open up this folder, you can see that I have 3 directories: the bin, the config, and the lib directory. So this is my installation, and this is my installation directory at the moment. I'll change some of the configuration settings. So if I go in here again, and I go into the config directory, this is where your configuration settings are stored. There's 2 files here, there's elasticsearch.yaml and logging.yaml. Elasticsearch.yaml is the main Elasticsearch configuration file, which allows users to change a variety of predefined properties and therefore improve and adjust particular settings for a use case. Some of the settings that can be changed here are the number of replicas to use for an index, the number of shards, the path to the config file and a data file, should there be a requirement to store these separately. The logging.yaml file allows the modification of the default logging option to assist with debugging of issues. So the changes I'm going to make are very simple. I'm just going to pull this over here. So I'm going to uncomment this and this. So the cluster name, I'm going to change that to something more appropriate, which will be CSCI-E-63, and I'll change the node name to primary node. I'll save that file and I'll close that. Okay, so that's the only changes I'm going to make to the configuration. Further information can be found on the Elastic site. The documentation is very adequate and in-depth. So now I'll start to run Elasticsearch. So it's on my desktop, so I'll do cd desktop Elasticsearch. So as you can see here, and from here I'll run bin Elasticsearch. And this is us now running. If I open back up here, I go to localhost 9200, you can see that the instance is running. So that's perfect. That's us up and running now. So the next thing we'll do is we'll install a plugin, which is the head plugin. This allows a user interface. This is an alternative to using the curl command. I just thought I would install this to show you how to install a plugin. Very straightforward in Elasticsearch. So this is a command. I'll just open up another window. We'll move back to our directory, desktop, Elasticsearch. I'll copy and paste this command. So let's put that here. I think I've got this command slightly wrong. Let me just fix this. So you can see the help is very useful. Nope. Plugin. Let's just do that. I think it's because I copy and pasted the. Yeah, that's better. Okay, so that's now installed. If I go here and I go /plugins, plugins/head. And this is plugin/head. Yep, you now have this user interface where instead of using curl, you can come in here and construct your queries to post and get information from Elasticsearch. The next thing we'll do is actually ingest a document. Providing the index, type and ID along with the corresponding data, we'll create an index, a type, based on a schemaless design and create the actual document. A domain-specific language, a DSL, is used in the form of a JSON object to pass the data to the API for ingestion and also searching. So we've got localhost 9200, which is the default port used for Elasticsearch. This is our index, this is our type, this is our ID for this particular document, and the -D specifies the data, and this is my data here. So this is my JSON object, which is contribution, the name, the candidate's name, the contributor's name, the contributor city, the state code, the zip code, the employer, the occupation, the amount, which is 25, and the date. You'll see here these are all strings, and this is an integer. Because of the schemaless design, Elasticsearch automatically maps these onto the correct data types. So what I'll do is I'll just run that in the command line to ingest this document. So now that's just put that over there. So this is the exact same as this. I'm just removing the white space. I push this. You can see that that's been added. Now let me just search, which is the next diagnosed document. After a document has been indexed, a query can be ran to return the document. Select all queries as follows. So what we're doing here is we're not searching for any parameter. You can do q equals. We're searching for nothing, therefore it will bring back the default settings, which is 10 documents, and bring back everything. We only have one document, so this is what we expect to see. The pretty equals 1 makes sure that we indent the JSON. I'll just place that here. As you can see, we've got the document back. So we've got total equals 1, which makes sense because we've only got one document. The max score equals 1.0. That's because we haven't searched for anything. So if there was 10 documents, all of the documents would have a max score equals 1. The index, we specified presidential. The type, which is contribution. The ID, which we specified also. The score, as I suggested. And the source field. This field stores all of the JSON that was passed in initially, but it doesn't index it, it just stores it. The next part of my presentation focuses on the solution I developed. The solution was built, which accesses Elasticsearch Java API to ingest, search, update and delete documents as an illustration of this technology. This was built as a Java project. I stored this on my GitHub account with a link here. You're more than welcome to go and get it, download it and have a look at it. I'll bring that solution up just now. So as you can see here, this is a solution. The first thing that you have to add is the corresponding jar files. These can be found within the lib directory here. Add these. and I've added 3 custom jar files. These are for accessing a CSV file, and these 2 are for dealing with JSON data. Before I got into the actual code of this project, I would like to speak about the data sources of the project itself. So if I bring up the data sources, so what we have here is we've got 2 data sources here. We've got the 2008 presidential campaign contributions, and we've got the states. So if I show you the